Hi students, in this video I'll be going through the JYSS 2021 Mathematics Prelim paper for 4E, paper 1, question 22. Right, so let's read the question. So the question says that we have a cumulative frequency graph which shows the distribution of heights of a sample of 240 children from ABC primary school. Okay, then in part A, we are asked to find the interquartile range. Okay, so we know that the interquartile is the difference between the upper quartile and the lower quartile. So we should try to find the upper quartile and lower quartile for this particular cumulative frequency curve, right? Okay, so the lower quartile is actually the 25th percentile, if you recall. So lower quartile, okay, which is also indicated by Q1, is the 25th percent. Okay, so let's try to find 25% of 240 children, because that's the total number of children in question over here. Okay, so you will find that you'll get 60. Okay, so basically what we need to do is to go to children number 60 on the cumulative frequency curve, and then we find out what is the height of that particular student. So 40 is over here, so 60 will be directly in between 40 and 80. So 1, 2, 3, 4, 5. So 60 will be over here. Okay, so use your ruler and draw a horizontal line. Okay, to go across. Okay, then you should be able to find the lower quartile height to be 1 to 4. Okay, so the lower quartile would be 1 to 4 cm. Okay, so let's try to find the upper quartile now. So the upper quartile is the 75th percentile. So 75 over 100 times 240 will give you 180. Right, so 180 will be directly between 160 and 200. So 1, 2, 3, 4, 5. So 180 will be here. Okay, so if you go across, okay, you will hit this. Okay, if you come down, okay, you should be able to find a height of 132 cm. Okay, so 132. Okay, so the upper quartile, which is also denoted by Q3, okay, is going to be 132 cm. Okay, so in this case, we will then be able to work out the interquartile range. So interquartile range is going to be Q3 minus Q1, which will be 132 minus 124 to give an interquartile range of 8 cm for ABC primary school. Okay, so I'm just going to label here. So Q1 and then Q3, all right? Okay, let's look at part B of the question. So it's given that 15% of the students are taller than HCM, so find the value of H. So if 15% of the students, only 15% of the students are taller than HCM, this means that we are actually looking at the top 15% of the students. So it cannot be the bottom 15%, because if it's the bottom 15%, then you use that number to find the height, right? The H, the value of H. You actually have 85% of the students having heights that are more than the HCM, right? So essentially here, you've got to understand that we are looking at the top 15% of the students. Right, so the top 15% of 240 students would be 36 students. Okay, if you go and do the calculation, 15 over 100 times 240 will give you 36. So essentially, we are looking at the top 36 students. So we'll start looking from the top, and then we will minus 36 students. So 240 minus 36 will give us 204. Okay, so 204 is actually over here. So we are looking at the heights of these top 36 students, right? Okay, so we'll just use 204. Okay, so this one should be 204, not 240. Okay, 204. Okay, we'll go over. And then once we hit the cumulative frequency graph, we'll go down and read that height. And the height will be the value of H, right? Okay, so if you go downwards, okay, it's going to be 134, right? Okay, so it's going to be 134. Okay, so you see the top 36 students will exist in this region of the cumulative frequency graph, right? So you see the arrow pointing outwards. So if pointing outwards means the height, we want it to be going this way, okay, which means that 1, 3, 4 and above. The top 36 students, their heights are 1, 3, 4 cm and above. Okay, meaning that the value of h will be 1, 3, 4, right? So from the graph, you can read that h is going to be 1, 3, 4. Okay, let's look at the last part of the question, which is the main part of the question that I want to discuss. Okay, the height of 240 children for 𝐿𝐶 primary school have a larger median. So there's another school. Okay, they also measured the heights of 240 children and then plotted the information in the cumulative frequency graph. It has a larger median and a smaller standard deviation. Okay, so these are the two key things: larger median and smaller standard deviation. Okay, if you look at this graph, there's 240 students. So the median height can be found by looking at the student number 120, which is over here. Okay, so if you look at this graph at 120, okay, the height of the student would be at this value, right? 128. Okay, so now you have another school. Okay, so I'm going to change the color of my marker. Okay, you have another school whose median may be bigger. So maybe the median has been shifted to over here, the blue cross. Okay, so if you were to try to draw a cumulative frequency graph through this cross, right, this blue cross, it will actually cause the whole graph to be shifted to the right, right? So that's one thing that we can say. The cumulative frequency graph, okay, for 𝐿𝐶 primary school is going to be to the right of the graph of ABC primary school. Okay, so let's write that down first, okay, before we address the smaller standard deviation. So one thing we can say, because the median is greater, right, for larger median for 𝐿𝐶 primary school, it's going to cause the cumulative frequency graph to be on the right, okay, of ABC primary school. So let's write that down. That's the first thing you can write. Okay, so the curve for 𝐿𝐶, okay, the curve or the graph now, okay. Okay, so maybe I'll use the word graph. Okay, the graph for 𝐿𝐶 primary school will be on the right of the graph for ABC primary school. Okay. Okay, so this one you don't have to write inside in brackets one. Okay, so this is due to the larger median. For 𝐿𝐶 primary school. Okay, so this is due to the larger median. Okay, secondly, okay, let's now address the smaller standard deviation. So if you recall, standard deviation measures the spread of data about the center point. Okay, basically about the mean. Okay, but over here we don't have the mean, so we can also assume okay, that is about somewhere about the median, right? So if the spread is smaller, it means that you can also think about this. The Q1 and Q3 okay, for 𝐿𝐶 primary school is also likely to be closer together. Okay, so you can imagine for 𝐿𝐶 primary school, these two lines, okay, Q1 and Q3, Q1 and Q3 is going to be closer together. So if it's closer together, how can you envision the graph to be? Okay, the graph would actually be more narrow, right? Okay, because if Q1 and Q3 is very close, then it's going to be narrow. So essentially, the standard deviation has a likelihood relationship with the interquartile range, and if the standard deviation is smaller, then the interquartile range should be smaller, then Q1 and Q3 should be closer together. So the graph is going to be thinner. So essentially, over here, if let's say small SD or low interquartile range, okay, the cumulative frequency graph is going to be thinner. Okay, so this one would be low SD, okay, small standard deviation, or low interquartile range, okay, or small interquartile range. Okay, then the graph is going to look like this. But if you have a high standard deviation, then the graph is going to be very wide. It's going to look look like this, right? It's going to be very wide. So it's going to be very wide. So this one will be high standard deviation and large interquartile range. Okay, so since they say that for the XYZ primary school, the standard deviation is smaller, right? So we could expect the graph to be more narrow, okay, in this way. So if more narrow, what we will look at is the center part of the graph. Okay, if it's more narrow, then it's going to have a larger gradient, it's going to be steeper. Okay, so it's going to be steeper. So the word to use is that for XYZ primary school, okay, the graph is going to be steeper in the middle as compared to the graph for ABC primary school. Okay, so we'll write this down first, then later on I'll show you on the graph. Okay, so it will also be steeper in the middle part, okay, in the middle as compared to the graph for ABC primary school, right? Okay, so it's going to be steeper in the middle as compared to the graph for ABC primary school. So the graph for XYZ primary school could maybe look something like this, right? Okay, so assuming maybe the shortest student is also 100, so it's going to go up, okay, go this way. Okay, but smaller interquartile range, so these two lines are going to be closer together. Okay, so it's going to be like that, okay? Yeah, like this. Okay, so steeper, right? Okay, so maybe let me redraw this part. Okay, so you can see that over here, right, the gradient. Okay, let me use a green color marker. Okay, the gradient here, okay, the gradient of this center part. Okay, the gradient of this center part is going to be larger than the gradient for this part, right? Going to be steeper, right? So this is how the lower standard deviation is going to have the effect it's going to have on the cumulative frequency graph, right?